Okay, so this is the second video of the review. Here we're doing really some problems in the 20s, 30s, 40s, and 50s. So the first one we're going to get to, we've already done problem 23 in the last video, but it's good to note that for 23, this symbol right here, it looks like less than or equal to, but it's a sideways U. This stands for subset. So this means a subset. In other words, A is a subset of U. Now, in order for A to be a subset of U, all the elements within A must be in U. So A has 2, 4, 6, and 7. Now I go over to U. I see a 2, a 4, a 5, and a 7. So I need to be very, very careful. Come on, Nancy. Hey, nobody cares. Okay, actually I do. I really can't wait to read that after this. All right, so is A a subset of U? In other words, are all the elements in A contained in U? Well, no. This 6 right here tells me that since I have a 6 in A and I don't have a 6 in U, then this is not true. A is not a subset of U. So this is going to be a big fat false. False. Why? I need to explain. Because, and I'll write a little because 6 is not an element of U. So, now we can look at 24. Is U a subset of B? So are all of the elements of U contained in B? What do you think, Kaylee?
Yes.
Yes? So every element here of U is an element in B.
Well, I think so. No.
Or are all the elements of B inside of U?
All the elements of B are inside U.
Correct. So then can we say that U is a subset of B?
Yeah.
Or is B a subset of U?
U is a subset of no. B is a subset of U.
Correct. B is a subset of U, not the other way around, right? So here, 24 says U is a subset of B. That is a false statement. False. Why? B is a subset of U. B is a subset of U, not the other way around. Let's just leave my explanation for that as B is a subset of U. All right, let's do 26. 26 is the empty set. Now look, this notation, I don't know how many times I've said this. This means empty set. Is the empty set a subset of U? In other words, is nothing less than or equal to U? Don't say it is less than or equal to U. But the empty set is a subset of every set ever. What? Here, I'll write that down. The empty set, this guy, is a subset of every... hang on now. Of every set ever. So, is the empty set a subset of U?
No. Yes.
Yeah, because it's a subset of every set ever. So it has to be a subset of U. So here, yes, this is true. All right. Moving along here. This is interval notation. Interval notation here says x can take on values between negative infinity and 1 or between 5 and infinity. So we need to graph this. I'm going to put 0 out there. Well, I don't want to put it there. That's a bad place for it. Let's put 0 over here. Yeah. And then we have 1 and 5. Now, with interval notation, we need to remember the brackets mean included. That's associated with less than or equal to, greater than or equal to. It's also associated with the closed dot. The parentheses means not included. Those are your strictly less than, strictly greater than, or the open circle. The other symbol we have is U, which stands for or. Sorry, union, which stands for or. They spelled out the or for us. That was kind of nice. So, to describe all the values between negative infinity and 1 with a parenthesis is my open circle here, so I put an open circle at 1. And then brackets at 5 means a closed circle at 5. So between negative infinity and 1, well, negative infinity is my left arrow, so I want to shade between my left arrow and 1, so I'm going to shade over here. And then 5 to infinity, well, in positive infinity is my right arrow, so I'm going to shade between 5 to the right. That ain't bad. Problem 41. So this says 13 equals 3 times the absolute value of x plus 2 plus 4. Now, remember, step 1, isolate abs val first. In other words, I want to get this on one side by itself. What's my first step there? Take away 4. Yeah. Subtract 4 from both sides. Killing it. So now I have 9 equals 3 times the absolute value of x plus 2. Next step.
Divide by 3 on both sides.
Yeah. Good. Somebody's learned something. Now I have 3 equals the absolute value of x plus 2. Now, this really says my distance away from 0 on the number line is 3. So what are the 2 possible values that are 3 units away from 0 on a number line?
Negative 3 and 3.
Negative 3 and 3. Good. So my first one is going to say 3 equals x plus 2. And this is, I want to say break apart here. This is how we break apart equalities. Break apart. Man, I hope this makes sense. Yeah. So the other option would be negative 3 equals x plus 2. Because those are my 2 possible distance away from 0. Anytime you see these absolute value bars, it doesn't matter what's on the inside. When you see the absolute value bars, in your mind, if you say distance away from 0, if you say my distance away from 0 is 3, well, there's only 2 options for that. There's a positive 3 and a negative 3. Now we can just subtract 2 from both sides. 1 equals x. Then subtract 2 from both sides. Negative 5 equals x. These are my 2 solutions. Here we go. Absolute value of x is greater than or equal to 3. In other words, my distance away from 0 is bigger than 3. So, when it comes to absolute value inequalities, my best suggestion when it comes time to break them apart, it has to be isolated first. Here it's isolated. I don't need to worry about it. I didn't have a multiplier out front. I have nothing adding and subtracting behind it, so it is isolated. Once it is isolated, then I break it apart. If it's an absolute value inequality, rewrite the original as is. Then you take the stuff in the middle, flip the sign, and make that value negative. Now, this I can graph on a number line. I know exactly what this looks like, so I get my number line out. Bam. And I get that going, get that going there. Well, my 2 values that I'm comparing x to are 3 and negative 3. Open or closed at 3 and negative 3, Kaylee? Closed. Good. So I have a closed dot at negative 3, a closed dot at positive 3. Now, am I shading in between or on the outside?
Outside.
Good job. We're going to shade on the outside. And I could tell that because x is greater than or equal to 3. Well, those are all the values to the right of 3. Here it says x is less than or equal to negative 3. Those are all the values to the left of negative 3. Now again, this is greater, and I've wanted you to say great or, so I'd put a little or right here just to remind myself.